Okay, class, today you were supposed to learn about section 2.5, perpendicular lines. So the note started out with the definition of perpendicular lines. They're two lines that intersect to form right angles. This little symbol here is the perpendicular symbol, so instead of writing out the word, you'll often see that used in its place. I drew the picture two different ways just to show you it's not always, a vertical line and a horizontal line. They could be off at an angle, but they're still forming right angles. And remember, in a diagram like this, even though we just put the box one place, if one of them's a right angle, really all four of them are going to wind up being right angles. Now, remember how we talked about every definition can be written as a biconditional? That's because the original if-then statement would be true, and its converse. So this definition is actually telling us two different things. And we're going to use this reason, this definition of perpendicular lines, as a reason in proofs. So you guys need to realize that it can be used two different ways. If you see that two lines are perpendicular, so if they're marked with the box or you're told that they're perpendicular, you can conclude that all four angles formed are right angles. Okay? Other way around too. If you're seeing two lines intersect and they're forming four right angles, you can conclude from that that the lines are perpendicular. Okay, let's go to our first theorem. So the theorem says if two lines are perpendicular, then they form congruent adjacent angles. So this is saying something slightly different than the definition. The definition talks about right angles being formed, so 90-degree angles. This talks about all four of those angles being congruent. Now they are similar, so it should be pretty easy for us to prove since it's so closely related to the definition. So we want to start our first statement as our given information. So line L is perpendicular to line N. So you guys see it using the shorthand of perpendicular. Our reason is given. Now I'm going to use the definition of perpendicular lines. It told me if I know two lines are perpendicular, then they form four right angles. So I've been told that L and N are perpendicular, so that means angle 1, angle 2, angle 3, and angle 4 are right angles. Okay, so that was based entirely on the definition. So that's the definition of perpendicular lines. Okay, now I want to think about what does being a right angle mean? We had a definition of a right angle last chapter. It said that they are 90 degrees. So I'm going to go from this statement to saying this, that the measure of angle 1 equals the measure of angle 2 equals the measure of angle 3 equals the measure of angle 4 equals 90. In other words, all four of them are equal to 90. That is the definition of right angle. Right? Now I have them all stated as being equal to 90. I have their measures stated as being equal. So I can state angle 1, angle 2, angle 3, and angle 4 are congruent. And that is simply the definition of congruent angles, that they have the same measure. So we have proved it. We can now use this. Let's move on to our next theorem, 2.5. So theorem 2.5, you'll notice, is the converse of theorem 2.4. It says if two lines form congruent adjacent angles, then the lines are perpendicular. You'll notice I'm not actually making us prove theorem 2.5 and theorem 2.6. So we're just going to talk about what the theorem means. Okay? So this case is saying if, let's say, we see a diagram, okay, and then we are told that angle 1 and angle 2 are congruent. So if angle 1 congruent to angle 2, we can see also they're clearly adjacent because they share a vertex and a side. So we have a case of congruent adjacent angles. We can conclude from that let's call these lines L and N, then L is perpendicular to n. So you're going from the fact that you know the angles are congruent and adjacent to concluding that that must mean the lines are perpendicular. Okay? Now if we were going to go through a proof of this, you guys would see that we would start by saying they're congruent and adjacent. We can use the angle addition postulate to state that they must be adding up to 180 since we see them forming a straight line. If they're congruent and adding up to 180, they must both be right angles, okay, which makes our lines perpendicular. Let's move on to theorem 2.6. So it says if the exterior sides of two adjacent angles are perpendicular, then the angles are complementary. So we have two angles that are adjacent, so something like this and this, that are forming two separate angles here. The exterior sides, so that's the one they don't share in common, so this side and this side. Okay, if I can see again, I'll just call these L and N. If I know that L is perpendicular to N, so if I'm told that those lines are perpendicular, which I can see are the exterior sides of two adjacent angles, then I can conclude that angle 1 is complementary to angle 2. Okay? Well, let's think about the reasoning behind that. If we know the lines are perpendicular, doesn't that mean that they have to be forming a right angle based on the definition of perpendicular lines? And remember what we learned about complementary angles, that they are two angles adding up to 90. So we could clearly see if that's perpendicular, that's going to have to be a 90-degree angle, and so 1 plus 2 would have to equal 90, making them complementary. All right, let's move on to the examples you guys should have covered in class. So we're given this diagram, and we're told that AB is perpendicular to CD and EF is perpendicular to GH. Then you're asked to name 8 right angles. So a good habit is to start getting, when you're told that something's perpendicular, marking it in your diagram with a right angle box. So I know that AB is perpendicular to CD, okay? And I know that EF is perpendicular to GH, so that would be a right angle box too. Kind of confusing because they overlap. So let's come up with 8 right angles. So I'm going to start using AB and CD first. So I would have angle AOD, I would have DOB, I would have BOC, and I would have COA. So that's the 4 of them that are from that set. Let's look at the other set now. So EF, GH, I'll start here, EOG. Then GOF, then FOH, and HOE. Okay, the next section, you guys were supposed to name the definition, postulate, or theorem that justifies the statement about the diagram. So here we have a diagram with lines RS and TV intersecting to form angles 5, 6, 7, and 8. So in number 2 it says, if 6 is a right angle, then RS is perpendicular to TV. So when you guys are trying to find this, you should be looking back through your notes for something where the hypothesis, the if part, talks about right angles, and the then part, the conclusion, says something about lines being perpendicular. Okay? If you guys find it, that is from our definition that we had right at the beginning of the notes today. Okay? It is the definition of perpendicular lines. It tells me that if lines are forming right angles, they must be perpendicular. So I'm using that form of the definition there. Okay, let's look at number 3. It says if RS is perpendicular to TV, then 7 is congruent to 8. So notice, it's saying something about perpendicular, but unlike up here where it was relating perpendicular with right angle, it's saying if it's perpendicular, it means angles are congruent. So you want to look through your notes for something that's written in that same form. If something about lines being perpendicular, then something about angles being congruent. And you're going to see it's the theorem we had in our notes today that says if 2 lines are perpendicular, then they form congruent adjacent angles. You could just summarize it just like that. Okay, notice I didn't refer to it by its theorem number though. We're not allowed to do that. We just have to summarize what it says when it doesn't have a name. Okay, last one, number 4 says if angle 5 is congruent to angle 6, then RS is perpendicular to TV. So when you're looking for what could justify this, remember it needs to be in this same form. So if something about angles being congruent, then something about lines being perpendicular. Right? And when you find it, it's going to be the theorem that was the converse to that last one we just used. This one says if two lines form congruent adjacent angles, then they are perpendicular.